what's termed our internal pacemaker. And note the terminology, nerve-like. Okay? All right, not that they are actual nerves. They function like nerves. So nerve-like pathways. If you look at this right here, okay, that is one heartbeat. It's very simple. The pacemaker of the heart is my sinoatrial node, located in the right atrium. When the sinoatrial node fires, watch the arrows, okay? We have impulses that travel down and across. So when the sinoatrial node fires, it sends an impulse down and through the right atrium and across to the left atrium. When this signal travels down to my atrioventricular node, my atrioventricular node has this nerve-like pathway to what is termed my atrioventricular bundle, also known as the bundle of His, H-I-S, okay? Now, this bundle right here, watch or notice what it does. It forks. It's also found in cardiac muscle. Okay, so this fork sends a pathway down to the apex and then back up through my right ventricle and my left ventricle. As we begin to fork and travel down, these are termed bundle branches. They do the turn at the apex. As they turn up the apex, these are going to end up leading to little fibers that look like they're extending into the cardiac muscle. These are termed Purkinje fibers. Note that they extend, do you guys remember papillary muscles? Okay, they are extending into a papillary muscle, sending that impulse to muscle that is connected to my chordae tendineae. And my chordae tendineae is connected to my tricuspid and my bicuspid valve. Now, how is it that the heart fills with blood? What's the pathway or what's the flow for blood into the heart? It comes into my atria, and then it's got to go to my ventricles. Note, from atria to ventricle, I have my AV valves, my atrioventricular valves. I have my tricuspid on the right and bicuspid on the left. But their cords are attached to papillary muscle which are fed by the Purkinje fibers, which are fed by the bundle of His, which is fed by the AV node, which is affected by my SA node. That means they're going to have the ability to help affect movement of those valves, which means that affects the flow of blood from atria to ventricles. Is everybody with me? The other force that's going to affect blood flow is pressure. All right? Now, might be thinking about blood pressure, high or low, sort of. Okay? But for the flow from blood from atria to ventricles, we are actually dependent on the pressure that can build within the chambers themselves. Now, like I said, the heart is innervated, but it does not depend upon the nervous system to function. Skeletal muscle is completely dependent on the nervous system. Skeletal muscle cannot contract without the nervous system. Smooth muscle is innervated. Does it depend completely on the nervous system? No, not really. But for the most part, it is controlled by that and the endocrine. The heart, nope, not at all. But what does it do? It affects the heartbeat. Both the nervous system and the endocrine system can affect the heart. They don't control it, they can affect it. If you remember, we have our sympathetic and parasympathetic. When we were talking about those systems, one of the things that we mentioned was under normal conditions, these two systems, they're kind of complementing each other. One of them's like making sure things stay up to date, helping with homeostasis, meeting the needs of the body. The other one's going, hey, let's relax. And then the other one's like, well, I gotta go back to work, relax, work, relax, under normal conditions. Okay, it's called tone, all right? Now, things kind of get, you know, like, let's say that we're getting ready to go take a run. We know sympathetic division kicks in, right? Because it helps us with increasing heart rate, increasing the respiration rate, all that sort of stuff, okay? Now, what these two systems do, they will help modify the heart rate and the contraction strength, all right? Now, that doesn't mean that there is control in any way, because that's the sinoatrial node. For the sympathetic, if you remember, gets everything ready. It's that fight or flight, okay? But it's not always fight or flight. It's just a part of life, okay? It's always working. So is parasympathetic. Do you remember? Do you guys remember how we talked about the areas of the spinal cord, okay? How we have our, the fibers, okay? We've got that sympathetic chain ganglia, how some of them had long pre-fibers, short post, blah, blah. Does everybody remember that? Okay. So what we're going to find for the pre-fiber, the pre-ganglionic fiber, okay, well, what that's going to do, it's going to go to that chain ganglia. Y'all remember the chain? Okay. and then some of it goes to the cervical. The post from the ganglia, it passes through what we know as the cardiac plexus. So that means the fiber from the sympathetic division that's going to lead to the heart, okay? It passes through what we call the cardiac plexus, goes by way of cardiac nerves to the heart. Look at where the fibers go. The fibers from the sympathetic division go to my SA and AV nodes, my sinoatrial, which is the pacemaker, atrioventricular, which passes it to the bundle of His for the ventricles. It'll go into the atria and ventricular myocardium muscle. It can, they do, lead to the aorta, my pulmonary trunk, and my coronary arteries. All of these areas are for the blood flow from the heart, okay? This would be nerves that if, let's just say, for example, I'm getting ready for the run. And like I said before, I don't run, okay? But it's a really good example, okay? Because people who do, you know, like do the jogging and marathons and all that sort of stuff, okay? What is one thing that's really important for them to do? Stretch. Ugh. Ooh. Ugh. Okay. Right? Right? Why? What are they doing? They're warm and warming up. What does that do to the muscles? They're going to be able to contract, but what is it increasing the flow of? Blood. If I need to increase that blood flow, don't I need my heart to beat a little more, a little faster? And this is what's happening. Okay, they're out there, they're warming up. Okay, and what they're doing is they're warming up the muscles, increasing the blood flow, because what that's going to do, bring nutrients to the muscle, making the muscle contract, getting that muscle warmed up, so we got a bigger contraction that can occur. In the heart, same thing. Now, kind of makes me think about how the heart is a muscle. People with really conditioned hearts, it beats, you know, for the most part, beats better and more efficient and all that sort of stuff, okay? But the heart is adapting. It's going to have a little stronger contraction strength. It's going to beat a little faster. It's going to move the blood a little more. All that sort of stuff. That's the sympathetic. So they go out, they do that run, that jog, whatever the case might be, okay? And then when they get to the finish line or when they're done, and they're, you know, depending on how conditioned they are, okay? So then they, you know, they got to do the cool down, okay? That's the parasympathetic, all right? Parasympathetic's coming in, and it's like, okay, well, let's kind of calm this down a little bit. Once again, my fibers, SA, AV nodes. Slow that heart rate down, decrease it, decrease that contraction strength, get that blood flow back to normal. Do you happen to know how long this process might take affecting the heart in a case of something like somebody doing a run? People who like run a marathon, let's say they go out and do like that 6 mile or 6K, whatever it is, okay? You know, they might go out and do that. It can take them up to a day for that heart to recover. In other words, get that heart beat, that SA node, the AV node and everything back to where it's under homeostatic conditions. Yeah. But that's okay, because it's what they train their heart to do. Okay?